This video is to show you how to do trend projections using regression. Regression is a great technique because it allows you to project beyond just the immediate next time period. You actually can project many time periods into the future because you establish a trend line. The only real trick to trend projection is sometimes they'll give you the years, the actual years, so it'd be 2010 and 2011, 2012, or they may give you months, January, February, December. You need to convert those into actual numbers. So this is time period 1 and time period 2 and time period 3. So you had a Monday of week 1, a Tuesday of week 2, um, a Wednesday of week 1, whatever the case may be. It would tell which one. So how do you distinguish between Monday of this week and Monday of next week? So Monday of the first week is 1, but Monday of the second week would be 8, if you can follow that type of numbering. So we just start at the very beginning of our time period and we convert them into a numeric sequence so that this reflects time period 1. So we don't worry about the year, the week, the month. We convert it into our first time period, our second time period, our third time period. And with that in place, you can then do what we call a scatter plot. And so I'm going to highlight the data, and then I'm going to go up and insert. In Excel, you insert a chart, and what you want to do is insert the scatter plot. If you go to Insert Chart, it'll bring up a menu. There will be a scatter plot. You hit on Scatter Plot. You want what's called the marked scattered. You don't want any lines connecting anything, and you will simply insert that, and there we have it. You want to double check to make sure it's doing everything correctly. I'm just going to delete this to get out of the way and make our chart a little bit bigger. You can see what it's done here. It's year 1, yeah, it did it correctly. Your years, your time period should be on the x-axis, and then whatever you're trying to predict or measure, in this case transplants, is on the y-axis, and so it plotted it correctly. Sometimes you might have to flip the columns before you actually chart it. We can now do a lot of different things because we know there's a relationship. It seems like every year, so in year 2 there are more, year 3 there's more, and so there's clearly a trend here. And so in your textbook they give you the formula for doing the intercept and the slope and creating that formula. Well, those formulas that they have, yes, you certainly can use those, and those will be on the formula sheet, but they're already built into Excel. So the first one I'm going to do is the y-intercept. So it's referred to as intercept. And then the things you do is you put in the known y's. So it asks for the y's first. So we're going to highlight the y's here, and then we're going to put a column or a comma, and then we're going to highlight the known x's, in this case time periods. And so we got a 42.6. Now I'll show you how you put that formula together. The other thing we're going to do is calculate the slope, S-L-O-P-E. Same thing, parentheses, known y's, and then the known x's. Okay, we now have enough to build it, because what we're trying to do is we're actually trying to draw a line. Regression-wise, we're trying to figure out where this crosses the y-intercept, and then also what the slope is. For every year increase, it goes up 3.2 transplants. And so with those, you can literally create a formula. We usually just do it this way. We'll sometimes draw a hat above the y. It's our predicted value for y. It's not the actual y, because we have the actual y's here. We're trying to do so sometimes we'll put that little caret sign, a little hat sign above the y, or sometimes we'll refer to this as y hat equals, and here's where you put in your formula. So you have the 42 0.6, that's your beginning point. So you have a minimum level of heart transplants. The minimum level of heart transplants not given any time period is 42. So if we don't think about any time period at all, there's about 43 heart transplants just automatically. For every year we've progressed, we've added 3 additional. So that's plus, because it's not a negative amount. You could have a negative slope, 3.2 and then x. So we now have a formula that we can use to calculate out that line. So they want us to actually calculate then what our heart transplants would be in year 6. So this is equal to 42.6 plus 3.2 times our x in this case gives us 61.8 would be our y hat or our forecast for year 6 because of the formula. This is basically the formula for the line. Now, there's some other unique features built into to Excel that you need to be aware of. With it plotted like this, you can actually click on those. I'm going to click on those, and then I'm going to do a right. Oops, I'm going to click once again. This takes a little bit of. I'm going to click on. I want to highlight all those, and then you can actually add into this. You can add in some different things. You can add in what's called a trend line. Let's see if we can do it here. If I highlight those, so I just clicked on those, and you'll see that all those data points are highlighted. Now if I do a right click, I can add a trend line. And what's nice about the trend line is you got some options. So you want the linear one by default, but you also want to bring up the options. And what you want to do is display the equation and also click the display r squared value on the chart. You'll see that it added this to it. We can move this out of the way so we can see it. You'll see that they wound up with the same formula we did. Now remember that Excel does things a little backwards. You would need to write this answer out correctly. So y equals the intercept plus then plus or minus then the slope of the line times x. It does it in reverse. So that's actually built into Excel. This other thing that I want to talk about is how we determine how accurate this one is. We could do correlation too. So correlation is built into Excel, equals CORREL parentheses, and you basically, it doesn't matter, but we'll still put them in the same order. Let's put in our y's. It talks about arrays, and then we'll put in our x's. Oops. Let's go back and do that again. So CORREL, and we'll put in our known y's and our known x's, and it'll tell you the correlation between these numbers. Well, correlation, the problem with interpreting correlation is there's only a couple things you can be sure about. If it is truly a 1, then we know we have a perfect positive correlation. Or if it's a negative 1, we have a negative correlation, a perfect negative correlation. 0 means that there is no correlation whatsoever. Usually it falls somewhere between 0 and 1 or 0 and negative 1. And so we can say now this is pretty close to 1. So it's almost a perfect correlation. But in other ones you do, you'll have it somewhere in between, and it's hard to interpret. You just can say it's positive and somewhere between 0 and 1. But somebody figured out that if you square a number, if you square this correlation, so I'm going to take this and I'm going to square it, use that hat sign to the second power, it actually converts into what we call the r squared. And the r squared means that 97% of this trend can be identified just in the time period you're looking at. So it's a very strong model. 97% of this data can be explained just by using the month. Now that'll become clearer as we look at multiple regression and associated forecasting. So that's it for trend projection. The next video will show you how to do associated forecasting, which is a slight variation of trend projection.